The question is simple. Have any of the systems on my network been compromised? The answer is harder than it should be. Enter AI Hunter. Active Countermeasures has automated and streamlined techniques used by the best pen testers and threat hunters in the industry to create AI Hunter, a network threat hunting solution that does the first pass of a hunt for you to identify systems that are most likely to be compromised and scores the results on a scale from 0 to 100. You can then research those systems in depth with AI Hunter. Focus your valuable time on the systems that need your expertise with AI Hunter. Sign up for a personal demo today at securityweekly.com/ACM. Welcome back, everyone, to Enterprise Security Weekly. Learn how to keep your internet self safe in our next webcast on August 13th. Register for all of our upcoming webcasts by going to securityweekly.com/webcast or /on-demand to view previously recorded webcasts. Brian Kelly is the head of Conjure Engineering for CyberArk. He leads the R&D teams focused on DevOps integrations and products. Brian has over 20 years' experience as a software leader, having been a VP of engineering at multiple technology companies prior to joining CyberArk. You can learn more at securityweekly.com/CyberArk. Brian, welcome to the show.
Thanks for having me. Good to be here.
Nice to have you on and talk about secrets. Not those kind of secrets, but application secrets, right?
Yep. And hopefully the end of them for at least applications. And
right.
That's going to be our little mission today.
Well, the end of them, like of having developers have to deal with them, right?
Exactly. So basically, we've gone through decades of engineers dealing with them, right? Passwords for your database, certificate private keys, you name API keys. And in all honesty, developers do their best, but it's a hard job. And if you look at the kind of stats on breaches and hacks, it's starting to become the majority that a lot of these major incidents happen because a very important password, a very important secret was not protected right by a developer. And it was logged somewhere or it was sort of held insecurely, stuck on a Post-it note maybe, but probably, was a major gap that led to that particular breach occurring. So that's what we're going to talk about.
Yeah, what's interesting, and nothing against developers, I developer myself as well, right? And I want to be focused on the functionality and making the application defensible, but I don't want to worry about how I access and store the secret, right? Like, I really just want to leave that to someone else. Like, let me make a call in my code and someone else take care of it, really, right?
Exactly.
That's basically what Conjure is doing in vaulting and tech in general, right? It's taking it out of the hands of developers.
Right. So developers have gotten used to a variety of technologies being taken off their hands because they're hard. So routing, DNS, a variety of things actually encryption of stuff on the wire. Nobody does that anymore. You have TLS for that. We're getting to a point with vaulting and secrets management where it's becoming complex enough and architectures are becoming different, with microservices, and they're becoming complex there too, that secrets management for developers is becoming proportionally harder as well, which with the kind of technology changes that are happening, there are some neat ways to approach that, which leads me to the whole secretless topic. And I'm sure when people hear something like secretless, their brain goes serverless and they get the whole hang on, there's still servers and serverless. So what the hell are you talking about?
But I just went through this just yesterday and today, right? Some writing and uploaded, it goes to S3. And if I think about it from a management perspective, I want my developer thinking about making the most functional and having the most integrity in their code to get a file uploaded. And there's a lot to consider. We do that a lot in our software, right? And a lot of other software where you have to upload something like, is it a duplicate? How many exceptions can I catch from the library? And I want to make sure I catch all of those. I want to make sure I'm raising, and we're writing in Python, right? So I'm raising all of those. I'm doing my error checking because I want this application to be as autonomous as possible and do its best to upload the file and bring it back to the user. But now what if we don't have a vaulting technology? I also have to worry about, how do I protect the secret? How do I get the secret? Where do I store the secret? Which secret does that give me access to? You know, what level of S3 bucket does that? I don't want to, as a developer, I want to make sure my file gets uploaded, right? I want to put all my development effort into that, not managing the secret.
Exactly. So, I've seen some of the most experienced, knowledgeable developers through my career do something totally by accident that increases risk or causes a problem with secrets management in their application. They might, upgrade some library that suddenly starts to log every HTTP request. And there it is. There's your traffic.
I was just going to say, you can very easily log it if you're not. I've done that before. Actually, I just took out some code that was for debugging purposes that was logging secrets in there, right? Like, that's bad. Don't do that.
And in an enterprise, where are those logs going? They're going uploading
everywhere
to some central, location for some aggregation facility. Really, really dangerous. So even with the best intentions, managing secrets is damn hard. Or, you might think you're doing a really good job. You've got a good rotation schedule. You've got your secret, of course, stored in a vault. But then you pull it into your application's memory. You do something with it. Are you zeroing out that memory? Are you garbage collecting it?
Right.
Or making sure that if an attacker jumps in to that machine, can they just look at the memory you've got in your heap or whatever and just pull it right out of there?
Right.
These are hard things.
Well, usually
even at the most sophisticated level, it's really hard.
Usually, you can just look at an environment variable, and some of the secrets are laying there too.
Right, that's where yours are. It's either that or in your GitHub repository.
Right.
It's funny. We talk about this sort of the evolution. CyberArk is, we've been doing vaulting for maybe 20 years. So as customers sort of get progressively more sophisticated with it, they start with the Post-it notes.
Yep.
Then it goes into source control. Then they're like, oh, that's a bad idea. Let's put it into an environment variable, but don't check it into source control. Then it gets pulled into, some sort of more secure place, maybe a vault. What we're talking about now, we're proposing a sort of a new architectural pattern that totally changes this perspective and the approach. We call it secretless because it truly makes applications have no secrets in them at all. So it's novel, it's different, and what we like about it is it's a fundamental guarantee that your application is far more secure than doing it any of the other ways.
Yeah, I kind of think of it like an API gateway, but just for secrets.
It has a lot of parallels for sure. There's definitely an overlap in the sense that the API gateway is going to hold some important things for you and just take things off your plate. And the critical sort of innovations in the technology space that are allowing this to happen. Number one is vaulting is crucial to a secretless pattern. Secretless just means there's no secret in the application. You still need secrets because your Oracle databases and your your APIs or whatever, they still need protection. So you still need a vault and you still need to have good rotation schedules and all that. What we're saying is, do you necessarily need to deliver that secret all the way down a TLS channel and then give it to an application developer who maybe has no idea about the OWASP top 10, maybe isn't very good about this stuff, or maybe just is going to have one of those accidents about logging? And we're challenging that. We're saying, let's just change the model fundamentally and then say to the developer, hey, would you love a world where you're not going to get the phone call saying your application got breached and someone stole secrets out of it? Wouldn't you love that plausible deniability?
So does that mean, sorry, Matt, I know you have a question, but does that mean that like if I'm authenticating to an API and then I need to reach out through that API, retrieve some data back, right, and process it, does that mean all of it goes through the vault, or are we decoupling the authentication and authorization process?
Yeah, so great question. I'll give you the quick overview here to give you a sense of how the pattern works as an architecture. So it's called a sidecar pattern, or you might hear it mentioned as a service mesh pattern. With your application, let's say it's deployed in Kubernetes or in AWS or somewhere, you also deploy the secretless, we call it the Secretless Broker. It's a small little, very tiny little process, only a couple of megabytes. and it is in line with the traffic. So you send your traffic through it, which is a very common pattern now with Istio or Linkerd or other service meshes. And you basically will make an unauthenticated call. So you call localhost and say, hey, just send your Oracle database query right through it. What the Secretless Broker does is it looks and goes, oh, I can see it's an Oracle, Oracle, whatever, HTTP, you name it, whatever protocol. It looks at the protocol and says, I can see that it's a request of this type going to this resource, which I know is privileged. I know that we don't have the secret for that yet. So I know I have to go and authenticate to the vault, pull that secret, but the secret's only pulled into the Secretless Broker, never given to the application. Then the request gets sort of augmented and we inject the secret into the header or however it's, whatever is appropriate for that protocol. And then we proxify the request over. So as far as the database or the endpoint or API is concerned, they got a call from an application and it presented perfectly normal credentials. And it looks just like it would in a non-secretless manner. The only difference is you have this little proxy application that's sitting right beside your app. And that's written in a very secure manner. It's doing the authentication to the vault for you. And it's making sure that memory gets zeroed out. We don't log anything. Right. It's doing all the good practices.
It's a request broker that's injecting the authentication. Yeah.
Exactly. But it's not a CASB. It's not a centralized one.
Right. It's per application.
Exactly. That model, the centralized one, increases your risk because if that gets breached, you're breaching potentially for a lot of people. This reduces the scope down to just your application. So it will only hold the secrets that the application requests and is authorized for, and it will zero them out and it'll get rid of them once it's done.
That's awesome. Matt.
Yeah, so that's where my question was going to go. Is it per application? Is it per microservice, which is based on, because you could have an application, a single application we were just talking about on the last segment that literally could be hundreds of components underneath. How do you scale the proxy to a highly distributed application? Is it based on which zones it's running in or how many microservices? How do you kind of architect that complexity?
That's a great question. So it was built with the microservices or heavily fragmented, heavily distributed model in mind. So you take your application and basically any process that you deploy, be it a Docker, a container, whatever, or even a classical sort of JEE app, where you deploy it is also where you deploy a Secretless Broker. And if you have like 10,000 Kubernetes pods, you'll have 10,000 Secretless Brokers sitting, within them. If you have 100 monstrous, Java applications or a million tiny Go applications, you'll have that many Secretless Brokers sitting alongside each instance. So if you have an auto-scaling group, you would have to also make sure that when you scale up and you spin up a new instance to handle traffic, that new instance should get a broker sitting in the same machine with it so that, everything just sort of scales in a very simple pattern.
Yeah, I have no problem with that model, right? Because we include all kinds of components inside of our components, right? And using Python as an example, anytime I import a library, I'm probably importing like tens of thousands of lines of code into my, into my application. So, having the broker on all my microservices isn't an issue for me anyway.
Right, and it's a small bit of deployment, but it's such a simple thing. It's a couple lines of config. It's a natively compiled binary. So, it's not going to add much to your deployment infrastructure or to memory usage, things like that.
It actually probably zeroes out, right? Because I don't have code inside my application that's trying to manage secrets or the vault, right? I'm basically just sending requests.
We never did the math on that, but I bet it's a net positive because what it does as well as it handles rotations. There's nothing want to see a developer cry is you tell them, okay, here's where you get the secret from. And they go, okay, I got it. I know where to get the secret from that vault. And then you say, FYI, every hour that password will change and you've got to handle that in your application. And they go, oh my God, So what we do, we recognize the rotation schedule and we can detect that, it's not valid anymore. And we will pull the new version of the secret from the vault, and reissue their query if needs be. And the developer and the app never sees an interruption.
Yeah, so you're caching it. You know when it changes, so you know when to go back to the vault to grab it again to keep the authentication mechanism working.
Actually, what's nice is for a lot of protocols, we don't even have to cache it. We basically, you set up, you might have an authenticated session. So you need the password from the vault to get the initial handshake done, and then we can evict it. And at that point, it's basically, it's whenever the endpoint says, your session's gone, you need to re-authenticate. But yeah, we can handle either scenario.
Brian, does it help me if I'm getting a new secret from the user? Does it help me store that, or is that a different process?
Might be it might be a slightly different process. You mean like somebody sort of out in the public using your app to put a secret in, or are you like their password or something? Or
in our application, right, and sure other applications too, right? The user authenticates to my application. Okay, I've validated the identity of that person. That's a separate process. Once they're in the application, I want to associate with their user account. In our case, their Twitter, right? So I'm like, hey, if you give me the keys to your OAuth for your Twitter account with certain permissions, I want to put that in my application so that at some point, based on behavior, I'm going to make a tweet on your behalf. It's one of the things our app does.
Absolutely.
Right?
Yes, absolutely. So basically, you would probably want to vault that, right?
Correct.
So basically, if you vault it, you're probably going to use it in some kind of web session or some API interaction.
Yep.
So that is definitely an appropriate use case for secretless, for sure.
So when I get those secrets from the user, I can use the broker to go put them in the vault, right? Or does
now the broker doesn't
put
things in the vault. You would just use the Vault API, the Conjure API to say upload a secret or put it somewhere. And
that
then
way it's not stored. I gotcha. It's not stored in my application after the user provides it to me. I go put it in a vault. I'm not storing anything in my app. If I want to access it again, I use the broke, for lack of a better term, the secretless.
That's right.
Yeah.
The Secretless Broker. Yeah, you got it. That's exactly right. So we see it as a kind of a sea change. Developers now, as I said at the start, they're watching more and more stuff get pulled into sort of a commodity layer that's handled by the experts. Tracing, even authentication, actually. If we look at a lot of the vendors building these platforms like Pivotal, Cloud Foundry, or what's now Tanzu, Kubernetes, they're starting to put client identities onto the platforms in the form of like TLS certs. And that's just a huge burden that's lifted off administrators, operators, et cetera, and developers. And if you look at the things that Istio or Envoy or Linkerd are doing in the service mesh space, they're saying things move around in DNS. Don't worry about it. Like manage that in this other plane, this other separate layer, and just have the developer say, make a request to localhost, and magic fairies and sprinkles will occur and things will just route their way to the right endpoint. Developers are, of course, embracing the heck out of that because it's awesome and that's the right way to go. We've come so far with security, with vaulting, which is absolutely the right way to go for managing secrets. This is the next level because we have this acceptance of local sidecar processes that will take things off your plate. We want to embrace push more security stuff in there because honestly, not enough security stuff has gone into the sidecar model yet. So we're really trying to make that happen.
Matt?
So when you think about the broker and the vault, how do you make sure that the vault's only communicating with the broker and there's not another bypass, right? I mean, how do you enforce some of that? That was a question that just came out of the Discord channel, which I thought was interesting.
Question. That's an awesome question. So basically what happens is the broker is responsible for authenticating to the vault just as the application would have done, without secretless in the picture. So whatever, the secretless broker can talk to multiple types of vaults. But let's say if it's talking to the Conjure, it would use the Conjure mechanisms for that. And we have a Kubernetes integration. So we have all kinds of usages of Kubernetes facilities to make sure that, that we know this application is really the bona fide application that it is saying it is. So it's essentially whatever your vault requires is what the Secretless Broker has to present for authentication, but it's doing it on behalf of the application that's sitting right next to it on the same host.
Right. And I would assume
Right.
you seed those keys, for lack of a better term, at build time, right? You're building that broker.
Not. We would prefer not to have anything at build time, like unless it's something non-privileged, right?
Mhm.
If you might have a situation where you have some multi-factor approach where you have some things that are from build time, but other things at runtime. For example, in our Kubernetes integration, we're using the Kubernetes backplane, like the administrative API, for sort of a verification that when an application comes up, it really is who it says it is. And there's a variety of techniques around that. But that's mostly a dynamic runtime thing because we want to avoid the secret zero problem where there's like, an ultimate key that has to be sort of put somewhere. We're really building a lot of flexibility in to avoid that by leveraging what the platforms are giving us, like these identities that are being presented by the platform. We're going to start using them more and more.
I gotcha. So it's not just like I get a hold of the code that's running the broker, right? It's also kind of tied to the application and the broker into one that's part of the authentication.
Right. So it's a new pattern. We have a couple of customers already in production with it. It's fully open source, I should mention as well. So we've got a bunch of people already sort of contributing new functionality and reach for it. And if anybody wants it to support their favorite database, it's got an amazingly simple sort of plug-in API to add that support. And it's one of those things that we really know its adoption is based on a couple of things, based on trust, that they can trust that the broker is going to do what it should do. So that's why it's open source. You can see everything it does. And also it's got to have a broad reach. So we have tons of support in there already. We have an HTTP handler, which kind of covers a lot of things because a lot of, pretty much every API out there is HTTP based.
Correct. Yep.
And some services too. So that's just configuration. You don't have to write any code. You just say, well, I'm talking to this API and it expects a base 64 encoding of a password, and it's got to go in this weird header with X something, and you just a couple of lines of config and you're off to the races.
I gotcha. So you can customize it. That's cool.
Right.
Yep.
So I was going to ask the difference between what's in the open source project versus what's in the CyberArk commercial product. You said a lot of this is open source. So how does this come into some of the more kind of enterprise offerings from CyberArk? Can you kind of describe the differences there?
Yeah, sure. So it works with both. So we have a sort of a full end-to-end offering from CyberArk that's in the open source, completely free area, and that is sort of if you think about Secretless on the application side, you've got Conjur on the server side, or what you would the vault side, if you will. So someone can take Secretless and Conjur, pull it down, and get completely up and running, and it's all free and open source. And if they want, they can, contribute code and get involved in our community there. They can also, if they're an existing CyberArk user and have a deployment, Secretless will, of course, work with the commercial versions of our stuff. So Conjur and the commercial version of Conjur called DAP, the Dynamic Access Provider, it's the same API. So there's, from the application's perspective, it's talking to the Conjur API, but whether or not it's realized by the free open source version or the paid commercial version, it's transparent. So if this customer wants to try it out and just trial it without ever giving us a phone call, that's totally fine. They can go to production that way too. If they want to, get the enterprise commercial features or link it to their broader CyberArk deployment, that's totally fine. They can also do it on their own, but we can certainly help with that as well.
Got it. So same APIs, you can test it out, convert over to the enterprise version later if you want some of those more enterprise features, support, et cetera.
Totally. Yep.
That's
outstanding. Great. Brian, anything else you want to share with our audience about Secretless?
Sure. I think, getting people to the website, secretless.io. We talk about it at conferences. We blog about it. We've got really, really set of interesting use cases. Every time we talk to a customer about it, they're coming up some really good questions about it. We'd love to hear, from people. We have a discourse community, and if they go to that site or conjure.org, which is for the Vault site, we'd love to just get engaged with people and or even just go to our GitHub and take a look at the code, pull it down, try it out. We'd love to hear from people who want to see it. Oh, actually, one more thing. Yes. If there's anybody who wants to help integrate it into other meshes, because if you already have Istio or Linkerd, it'd be really interesting to see if we can start to coalesce those and see if we can get the secretless pattern adopted in other mesh technologies too.
Outstanding. Brian, thank you so much for appearing on Enterprise Security Weekly. Our listeners can learn more at securityweekly.com/CyberArk. Also, if you are wondering what Black Hat 2020 in its virtual form is going to look like, coming up next is our pre-recorded interview with Steve Wiley, General Manager at Black Hat. So stay tuned.